Hi guys, we're back with another video tutorial to talk about the VFX or the procedural effect that we are implementing in this series. Today we're going to be generating the actual mesh that we're going to be showing in when we hit play. This is we've done this pre-visualization of the wire sphere that we are going to generate, but it actually doesn't work, and if we exit it stops rendering it. So now it's time to implement this method, the method that is called when we hit this button. So this is the method. Yeah. So basically we have to generate a new mesh that sort of follows that path. First thing probably would want is to give it a name and to have a path for the mesh that we're going to generate. So let's do that. String name, and we're going to call it wire sphere, for instance, and private static string folder is going to be assets and art models, for instance. And we're also going to have a constant, and we're going to do it here. Yeah, I don't think we need it. Well, yeah, that's I think it's const string extension, which is the file extension, and it's going to be .asset. So as opposed to these values which are floats or integers, and you cannot set them directly. In here, what we want is to set the set the name is probably in the same way, but to set the folder using a file dialog. So, well, we'll do that in a particular manner. First, we'll use the normal way, so the normal editor UI layout, GUI layout for the name. Editor GUI layout. It's not going to be name; it's going to be a mesh name, because name is something. It's not. Name is used in most Unity scriptable objects to define the name of the object, and this is something you want to avoid here. So it's going to be text field. It's going to be called mesh name or mesh name. And for the other one, we're going to be doing editor GUI layout, horizontal, and horizontal. Let's do it like this, and then we're going to have, on the one hand, we're going to put the folder is going to be editor GUI layout, text field, folder, and on the other hand, we're gonna put a button. If we layout button, we're gonna call it 3 dots, which is a standard to say, okay, we're gonna open a file dialog, and we're gonna do a layout options. I think it's GUI layout dot max width. We're gonna set the max width to something small here, something like 60. And what happens when we do this? We're gonna open the dialog. So was it? I don't remember. What is the so let's, when you don't know something, just search for it. So dialog, folder dialog Unity. So we want editor utility. That's what I was looking for, and that is part of editor utility. Open folder panel. The editor. Yeah. So we should already have it. Editor utility. That's it. Open folder. You see, this displays the open folder dialog and returns the selected path name. So the title is going to be directory to generate the mesh, to put the mesh asset. The folder will be folder, and the folder name would be folder 2, I think. And a string new folder. So if new folder, if not a string is null or white space or empty or whatever, new folder, and folder is not new folder, then just update it. Well, actually that last part is irrelevant, so folder equals new folder. So basically with this we're showing a button. When we press the button, we show a dialog to select a folder. So let's see how this shows in the window when it compiles. So now, and how long it takes to compile the new Unity. And you see, you got the mesh name, which is called wire sphere, and then the folder, which doesn't exist. So if we put it like this, then we got this, and then we can do new folder, the models, and then select that one. Oh, yeah, that's right. It didn't update, but it worked, which is good. So yeah, this is the same thing. There we go. That's all right. Anyway, so this is working, and if we one of the things we haven't done is, since we have changed the folder structure, we haven't updated the assets. If we go now to Visual Studio and go back or somewhere else, then we'll see that it updates. But if we don't tell Unity that something external has changed, it's not going to update on its own. In this case, we can force that by doing this and then doing asset, database, refresh. Okay, anyway, this seems to be working and it's good. So now it's so now we have to create the wire sphere. So the first thing we're going to do is generate a mesh, and we are and we're also going to be when we're going to be creating a mesh, but we're also going to be creating a game object in the game, in the scene that we have open, to showcase the mesh that we just created. Okay, so so the first thing is we're going to create the mesh. So we'll So mesh, call it new mesh. This is an empty function, but this is useful to just create the structure that we're gonna be so the structure of the algorithm, and then we go in detail. So no, first that, then store the mesh in the asset database. So no, create asset. So it's going to be the mesh, and it's going to be the path. So string path is string file name is going to be a name plus extension. That's going to be the name of the file, and then string path is going to be we're going to be using system.io. So we're going to be doing path combine. It's going to be folder file name. Yeah. So this creates the asset. Then maybe we do a refresh. Possibly it'd be good to do something like is asset database. Look as the path. Yeah, that's it. So mesh is gonna be that. So we load the actual asset. So this is the shared mesh that we're gonna be using, and we're gonna create the mesh object in the scene. I'm not sure we need to do this line. We will see. We'll see later. So this one is going to be create a new game object with a mesh render to show the given mesh to draw. Basically, this is going to be easy. We just create a new game object. New game object. We give it a the name that we have. This name. By the way, when we set name here, we should set mesh name. Then we create a mesh filter. It's going to be object a component mesh filter and a mesh renderer. So we create the object within the components, and then filter, which is going to be easy, and a shared mesh is going to be the mesh, and the renderer. We should only set the material, but this is going to be null for the time being. We could have a default material, so yeah, we could do that. So this is going to be this one, yeah. So string, the object, the type, and whether we load them or not, false. As material. And here what we do is exactly that, default material. So we have a very basic structure for the algorithm. Actually, we're gonna be putting this up here because this is gonna be a lot more complex. So this is the easy part, like the whole structure of how this is gonna do. First we create a mesh, then we save it to the database, and then we create an object on the scene. Let's see if this works, and then let's go on working from there. So it looks like we have missing a semicolon. Yeah, oh yeah. Oh, damn it. This one goes here. So we can create actually a material here, a folder called materials. We create a material. And this is all right. I mean, yeah, this is fine. Cool. So good. We give it this one and create a wire sphere. So we have created it. There is a new model here, wire mesh. It's got 0 vertices, 0 triangles. I have this, which has got this wire sphere here. Cool. And the full wire sphere mat. Good. This is working. It is doing nothing, but it's at least the part that the whole structure that we have just developed is working. So now it's time to create the actual mesh. So one of the things we're going to do is give it a name, because why not? So let's create the arrays we're going to be using. So we're going to be definitely needing the vertices, and almost we're not going to be giving it UVs or well, we could have UVs actually, and then we'll need the triangles. We're not going to give it any more information, not tangents or colors or whatever, and then we need the indices. So in order to create these arrays, we definitely need to know how many vertices this wire sphere is going to have. But that should be reasonably easy. Number of vertices is going to be 4 because we are going to be doing a diamond shape. So it's going to be 4 times the number of iterations in each yaw steps times the number of pitch steps. This is going to be the number of vertices. The number of triangles is a little bit more complex. This is actually, we're going to be having all of these, and we're having all these vertices, but we're going to be connecting the first one with the next one, the next one, the next one, and then when we go to the next circle, it's going to be doing the same. It's going to be connecting the last one with the next one. So actually, we can think of it as a 4. So this is the number of steps that we're going to be doing minus 1. So and this is going to be times 4 because they're no, we don't need 4 because there's already 4 sides, so that's times 6, because there's 6 indices per quad, because we have we're going to be doing quads, which is basically 2 triangles, and 2 triangles between, for one of the there are going to be 2 triangles for one of each of the sides of the diamond, which there are 4, which means that since there are already 4 vertices, that's what you need. So there's going to be a new vector 3 embeds, new vector 3 embeds, new vector 2 embeds, and there's going to be new indices. So we have created the arrays. The vertices, calculate the indices, assign all the info to the mesh. So again, I'm gonna be writing the whole algorithm first, and then writing what it has to do, even if we're not actually implementing it, and then we're gonna be going one step at a time. So assigning things to the mesh is the easy part. So we just say vertices, normals is going to be normals, UV is going to be UVs, and triangle is going to be indices. That's all right. We can now recalculate the bounds. We could recalculate the normals, but I don't think we want to. And that's it. So let's go fill in the vertices. In order to fill the vertices, we cannot do a I pitch. I'm gonna call it like IP lower than. So it's IP stands for iterator pitch, num pitch steps plus IP. So basically here we do something very similar. T pitch is gonna be float IP divided by float num pitch steps -1. So there we go, and with that we can calculate the pitch. It's gonna be vector_rad, and it's gonna be flerp. So minus max pitch angle T pitch. So now we have the pitch, and with that we can calculate the sine and cosine. The pitch float calculate the y position radius of the circle. So y is going to be, as we said, sine of pitch times the radius. And the radius is going to be cosine of pitch times the radius. And now iterate the yaw. Your steps. So we do exactly the same thing here, I can already copy it. Yes, it is. This is gonna be your your steps. And we're gonna, on the other hand, this is different since we just can multiply this times TO because no, it's gonna be math of pi times 2.0. So we go from 0 to 360, but not exactly. We don't want to finish where we started. We want to finish a little bit before that, so we want to divide by the number of your steps. So 0 is going to be 0, and the last step is going to be not 0 again, but somewhere else. With this, we have the yaw. So with this, we calculate the x and y position. It's going to be sin yaw times inner radius. Float C is going to be cos yaw times inner radius. With this, we are going to calculate a so we are going to calculate the axis too. So we got the position. X, Y, Z. That's all right. But we have to calculate the axis. So what are the axes going to be? So we definitely want this to be basically you want one of the axes to be Y, so 0, 1, 0, and the other one to be basically sin yaw cos yaw, so in X and Z. These two axes, I mean, you could have a third one, which would be forward, would be minus cos yaw sin yaw, but we don't actually need that one because we're only working on the on a plane. With this, we can calculate the procedural UV of the current point, the current of the wire vertices. So the UVs, for the UVs, we're gonna assume that you get a whole U for a whole circle, and the V is going to be from, we're gonna do there are several ways of doing this, but I like the way of doing it with going, so half the top part of the wire is going to have the full from 0 to 1, and then and the belly of the wire is going to have from 1 to 0. I hope you will understand this. The UVs are a tough thing to explain without a whiteboard and something else to show you, but they don't matter so much because we're not using textures here, so you shouldn't be too worried about it. So there's going to be 4 vertices. So end base index is going to be yp times num your steps plus yy, and all these times 4. And then its vertices base index So this is gonna be, now instead of doing it like that, we're gonna be doing it like pos plus, we're gonna start with, for instance, right, plus thickness times right, vertices base index plus 1 plus thickness times up. Again right and again up, but here we're gonna be minus and minus. Normals base index plus 0 is gonna be right up minus right minus up. With regards to the UV, this is going to be new to TO 0.0. So 1, 2, 3. It's going to be 0.5, 1, 0.5. This is in theory generating all the vertices that we need. And now we have to calculate the indices. In order to calculate the indices, we have to do kind of the same thing here. So we have to do nested loop, but we don't need to calculate all the geometry. We only need to make sure we breach the one node with the next. You can think of every one of these iterations like a node, and probably we don't even need that. So we can do simple array with this. So we could do something like int num nodes is gonna be num vertices divided by 4. So we do it, we iterate over num nodes minus 1, and here what we do is we connect each node with the next one. The order is important, and you're gonna have to bear with me here because I never remember what is the right order to use. So I'm gonna be doing some tests, and then I will see if it works, and if not, I will just change the order of the indices to make sure the normal is pointing the right way. So basically, we're gonna be filling the side. Imagine we're in node 0, okay? So we're gonna be breaching the vertices 0, 1, and 4 and 5. because those are the vertices of the next node. The 0, 1 vertex of node 0 is 0, 1, and the 0, 1 vertices of node 1 are 4, 5. So we can have we're going to repeat this 4 times. So we're going to be doing 4 and j equals 0, j minus 4 plus j. And next, j is j plus 1 mod 4. That means when we are in the third vertex, we're going to be joining with vertex 0. So indices. So well. So and base index is gonna be 6 times 4 times I. And here we're gonna be doing base index plus 6 times j plus 0. And this is gonna be basically base vert index. It's gonna be this, the vertex index is gonna be simpler than this. It's gonna be 4 times I. Plus j. So 1, 2, next j plus 4. So this is going to be in the next one, and it's going to be 3, 4, 5. I believe it's not. This is something like this. It's j plus 4. This is going to be so 1, 1, 2, 3, 1, 2, 3. It's 4, j plus 4. Yeah, I think it's like this. So basically, these are two different triangles. It's this triangle here is one, and this is another triangle, and the two of them should make a quad. But to be honest, I'm not sure. The only way to know for sure is running the program to see what it does. Well, we have something. Not sure it's well done, but it's something. Yeah. So yeah, it looks like it's the normals are pointing inwards instead of outwards, and that is my fault. That is exactly what I meant when I didn't know if this was the right thing to do. So it's not. So the easiest way is to change this and to change this. We just change the order of these two triangles. We can create the wires again, and here we go. Yeah, that's correct. That is so much better. Yeah. So even with these, it is you could have more steps. So yeah, that's all right. But let's create more steps. Let's put it to 24, for instance. This is looking even better, I think. We could even go to 32. I think this is too thick. Yeah, it looks better. This looks a lot like what we had before, right? yeah, let's get. Oh, I call it effect. So the scene that we just created here, yeah. And yeah, we are generating this. This is obviously there is no light mouse, but this also generates some basic stuff about the environment. So now it's using the skybox properly for the indirect lighting, and it looks better. We could still would probably check later whether we want this environment or we want another one, but it looks good enough. If we close these, we can see the. This is still. There's too many vertices. We could still do better, but then we're gonna be seeing this from this distance, and that's all right. So I think we have what we wanted. So summarizing, we have generated a mesh completely procedurally. If you look at this mesh here, yeah, this is the mesh that this generates. It's got a 1700 triangles, over 8,500 verts. It is doing exactly what we wanted with him, and it is all done with math. So we haven't used a Blender or any other 3D modeling package to create this. We just did some math, and in Unity with code we created this mesh. I think it is important to understand this. I think it's important to understand why that you can generate mesh with math, because in the end that's all that it is. What you have in those vertices, it's basically just numbers. So we just did. This is basically iterating, doing a nested iteration in spherical coordinates. So over the yaw and the pitch of a sphere, and joining the nodes. And then later on, this part is bridging those nodes, considering each node to be one of the 4 vertices, and bridging those nodes, bridging the side of each of those nodes. So you have 4 vertices, 1, 2, 3, 4. So you have 4 sides because it's a diamond, and then you bridge this side from 0 to 1 with the next one, which is also vertices 0 to 1 of the next node. And that's what we've done here. The same with 1 to 2, 2 to 3, 3 to 0. This could actually, we could even, now we're setting the number of, this is a 4, which is kind of annoying, which we could have like a private const int num steps for the section 4. By the way, we're gonna put this to 64.